if you have one boy that has blue,
Yeah.
then
If you have one boy that has blue, all of the boys have to. I mean, all of them have to be boys and have to wear blue. But then it says both boys and girls.
Yeah, do you understand that? So if any boy is blue, if there is a boy that's blue, right? Then it forces the whole circle to be blue boys.
yeah,
Do you understand?
But then it says boys.
Because blue forces the next one to be blue, right?
Yeah.
because like it has.
So sorry, boy forces the next one to be blue, right?
Yeah.
But blue forces the next one not to be a girl, right?
Yeah.
Because girls need it to be red before, right?
Yeah.
So then it forces it to be a blue boy, right?
Oh yeah, yeah.
And if you do it once, then you can do it all the way around, right?
Wait, so that means the boys must have a red shirt and the girls must have a blue shirt.
Yeah, so the boys must, if there are any boys, they must have a red shirt, right?
And then we could just like.
But why did you say the girls must have a blue shirt?
Because like it's the same things with like the red girls.
Yeah, it's the same kind of thing, but what is it? Tell me exactly what you're trying to say. What's the same thing?
Like how if it's a red girl, then there has to be another red girl there.
So if there's a red girl, you're saying where has to be another red girl?
There has
Like
to
on
be
the
a
left, there has to be
Yeah.
another
girl behind it.
girl, and then since there's a circle, it just goes like
It goes all the way around, right?
circle.
So that means all the boys must be in red and all the girls must be in blue, right? That's
Yeah.
crazy, you know?
Wait, so we can just tell them the seasons, right?
So all boys red, all girls blue, yeah? Okay, that's definitely progress. You'll get like,
Oh wait, it's very close to the answer, but we can't get that. Yeah.
Yanni, do you have a microphone? Lucas, are you still with us? Oh, okay. Lucas, are you still there?
I think he is.
Even if
It
it's
says
in
four
the Zoom.
days.
Yeah, but even if it's in the Zoom, we could be doing something.
Oh yeah.
Okay, so that's great progress, okay? So all boys are in red. So now you don't have to worry about the colors. You just have to worry about if they're boys or girls, right?
Yeah.
Wait, we just have to figure out like which one goes first, right?
We can just start with any of them. It's just one starting point of the circle.
Yeah, but then
circle is
we'll
like
go one more.
yeah. So like once we figure
There's
out the
gonna be
first one,
one
we figure
person.
out the second one, and then so on through the circle because it's a circle.
Mm.
Yeah, but it's gonna be like if we do boys,
If we start
It's
with a
gonna
boy,
be-
then it's
it's
gonna
gonna be boy, girl, boy, girl, boy, girl, and so
Yeah.
on. If we start with girl, it's gonna be girl, boy, girl, boy, girl, boy. Does that make a difference? Like, it makes a difference, right? Like which ones goes first, but then there'll be like if
no,
the
make no
girls.
difference because like if for example the first one starts with a girl, the one before that is a boy, and then if you go through the whole circle, the last one before the girl is going to be a boy.
Okay, so you're claiming that if I start with a boy, yeah? If I start with a boy, you're saying the next one has to be a girl? The one next clockwise person has to be a girl?
Yeah.
Why is that?
Because it says after.
Because all girls are blue and the boys clockwise neighbor has to be in a t-shirt.
Okay, good. But then what does the girl say?
And
And
then
the
it has
girl
to be
needs
a boy.
because all boys are red, so it's gonna keep going boy, girl, boy, girl, boy, girl.
Are you sure? Because
It's
like the boy tells the clockwise thing to be a girl, right?
Yeah, but like.
But the girl doesn't tell the next clockwise person to be a boy.
But So, for example, boy
Oh,
and
yeah.
girl, and then
Oh,
you
yeah.
put another girl. It can't be that because
Oh,
the one before still has to be a red one.
Wait, no, it can be. Wait, no. Yeah, it does have to be
Okay.
a red boy because if it's a blue girl, then anti-clockwise to it is the
girl.
blue
Yeah.
girl.
Blue,
Yeah.
the girl can't be blue, so
it's always gonna go and it's just gonna go
boy,
boy, girl, and so
the
on.
answer is yes and 10.
Wait, since 20 is an even number, it doesn't make a difference. They're just gonna have like 10 boys, 10 girls, right?
Yeah.
But the answer is yes.
Okay, so that says if it starts with if there's a red boy, it'll make it go around like that, yeah?
Yeah, but it doesn't matter which one goes first. Since 20 is like an even number.
Yeah.
It's just gonna be half boy, half girl, which is 10 boys and 10 girls.
Oh, well, you guys made short work of that. Do you guys understand that?
Yeah, it's
That's
pretty fun.
pretty nice problem, right?
Yeah.
You guys have any questions online? So the thing is, how to explain that in a proof, do you understand?
Oh.
So how do you explain that in a proof, huh?
Like, since all boys, because if the boys, one boy is blue, there has to be only boys and they have to all be blue. So
Yeah.
that means all boys have to be red, and same goes for the girls, so they have to be blue. And then
So you kind of do it in this order, right?
First
So,
part of proof is
like,
explain how all boys are
yeah.
and all the girls have.
Yeah, like so basically when you have a proof, right? It's like you have a statement you want to prove and then you write the proof. Does that make sense?
Yeah.
But to prove it, you can actually have a lot of little statements and little proofs along the way, right? So for example, your first statement could be all boys have to be red. Yeah?
and all girls have to be blue.
Yeah? And you can make all girls have to be blue the same statement, or you can just make it a second statement, right?
Yeah.
And then you can prove these statements separately, right? Okay, and then your third statement could be, you know,
It has to be a boy as well.
if there is a red boy, yeah, then it has to alternate red boy, blue girl, right?
Because
And it's the same for.
And then you just prove it.
Yeah, and then you prove it. And so before it could be if there is a blue girl, right? Then it alternates, right? That makes sense?
Yeah.
Okay. And then, so this thing I want to tell you next, it's a little bit, there's also skill in trying to prove this efficiently, okay? So how would you say it? So if, for example, the first two statements we know how to prove. The first one is like, if one of the boys is blue, then they all have to be blue boys, yeah, which is not allowed, yeah? Okay? And the second statement is like, all girls are blue, so we say, so this is called proof by contradiction, you understand? You suppose it's not, the opposite is true, yeah? So if there's a girl that's red, yeah, then all the people have to be red girls, right?
Yeah.
And that's not allowed in the question. Okay, so that's like an argument by contradiction. Okay, so that's called argument by contradiction. No.
Someone told you check this code in chat.
Okay. Okay. Focus on this. So the word contradiction, I should probably write out clearer. Contradiction. Okay. Yeah, sometimes people don't know what you're saying, and if you say contradiction, it kind of tells them roughly what the idea is going to be, right? Okay. So there's sort of a clever way you can save time because both arguments are like the same, right? But if you're just beginning, you probably just want to write them both out. Yeah? Because you could actually just save the argument by replacing girl with boy and red with blue, right? It's symmetric under these kind of replacings. Okay, now the third statement, if there's a red boy, then it has to alternate. So the way you argued it was you start with the red boy, then because it's red, the next one has to be a girl, right?
Yeah.
Well, the next one can't. So because it's a boy, the next one has to be blue, right?
Yeah.
And because it's blue, it has to be a girl from the second statement, right?
Yeah.
And if it's a girl, then if it's
It can't be a girl again.
yeah,
Otherwise, that girl, the one
Yeah.
before the girl would be blue.
Clockwise would be a
So
blue girl.
therefore,
yeah. So because it's blue, it has to be a girl, and because it's blue, the next one has to be a boy, right? And because by the first statement, because all boys have to be red, there has to be a red boy, right?
Yeah.
And so you go all the way around until you get back. So then there's 10 girls and 10 boys, right?
Yeah.
Okay. So statement number 4. Okay. So if there's a blue girl, then it alternates, right?
Yeah.
Well, you could just repeat the argument and prove it again, right?
Yeah.
But you could actually make use of your other statement, for example. Okay. So what you could do is you could start the argument like this. Okay. There is a blue girl, right? Okay. Because they are blue, right? The one before, because they're a girl, the one before them has to be a red, right?
Yeah.
Does that make sense? And because all the boys are red, okay, and all the girls are blue, that means that has to be a red boy, yeah?
Yeah.
Okay. And because there's a red boy, okay, you can now apply it to statement 3, yeah? So instead of carrying out more arguments, you can literally use statement 3 to conclude what you want to conclude. Does that make sense?
Yeah.
So it saves you the time of going through the whole argument again, right?
Yeah.
Because statement 3 says if there's a red boy, then you can finish the whole way, right?
Yeah.
And so for statement 4, you don't have to go the whole way, you just have to get to a red boy. Yeah?
Yeah.
Okay. And then because they're alternating and there's 20 people together, it has to be 10 boys and 10 girls.
Yeah.
Right? Alright. Okay, so where do these problems come from? Okay. So the reason I show you these problems right now, these problems come from Tournament of Towns, okay? They're